Okay, I think we'll go ahead and get started. Hello, thank you for joining us today. This is the Utah Water Supply Briefing for April 7th. My name is Brenda Alcorn. I'll be presenting today. Other forecasters that in the Utah, different basins in Utah are Trevor Grout and Patrick Kormos. This webinar is being recorded, and the slides and recording will be available on our webpage later today. If you have questions as we're going along, we do have some people monitoring the question box, or you can raise your hand and we will get to you. So in today's briefing, we're going to talk about the weather and snowpack to date. Then we'll get into the water supply forecasts. We'll talk briefly about the upcoming weather. And since we were not able to have our peak flow forecast webinar that we usually do in March, we will be going over some peak flow information today in this webinar. So to start, we'll just talk about what happened during March. So these are daily precipitation maps. They're backwards. So up at the top right is the end of the month. Sorry, the top left. And down over on the right side at the bottom is the beginning of the month. And basically, it was wet. It started wet, it ended wet. It was wet in between. We had very few days that were dry statewide, and we had quite a few big precipitation events almost weekly during the month. And so when you look at that as a monthly total, and then add that into our whole water year total, from October 1 through the end of March, the graphic here on the left is the monthly precipitation percent of normal for each of the major basins in Utah. And what you see is that March is the last bar, kind of a dark green color on each of those. And it was greater than 200% of average precipitation for the month of March in basically all of the basins. The severe was only at 195%. So as I've mentioned, and as I'm sure you're all aware, it was very wet across the entire state during the month. And so when we look at this on the water year total, in the next chart, what you see is all basins have seen much above normal water year precipitation to date. And you can see those numbers in the table on the far right. Anywhere from 135% to 170% of average for that October through March total. And we can look at, these are the maps of the March precipitation on the left and the maximum temperature deviation for March on the right. And so what you can see is on the precipitation map, a lot of purple area, which is 200 to 300% of average. And then looking at the temperature map, you see a lot of bright blues, which is greater than 9 degrees below average for the month. So basically it was a wet, cold month, again, across the entire state. And this allowed the area to hold on to most of the low elevation snowpack through the entire month. And so along with the cold temperatures, it really held back any type of snowmelt. So there was really minimal snowmelt during the month, especially in northern Utah. And so you can see in the map on the right, this is from the USGS, and it's the monthly average flows as a percentile. And you can see most of the state is in the below the 25th percentile for flows during the month. And even the green areas that are the normal, the 25th to 75th percentile class, those are really on the lower end. The exception was down in the Virgin River Basin of Southwest Utah, where we did have a few lower elevation rain events during the month, even as it was building snow in the higher elevations. And in the middle of the month, there was a storm down there that did cause some flooding in some parts of the basin. And so that is why you see down there that it shows above normal stream flow during the month for the month as a total. And you can see I've put on the hydrograph for the Virgin River near Bloomington, and you can see there it did go over flood stage with that event in the middle of the month. Next, we need to talk about what's happened so far in April. So the forecasts that we're going to be talking about are April 1 water supply forecasts, but of course, in the midst, while we were making these forecasts, we were having a significant precipitation event in the northern half of the state. So the first week of April continued that cold, wet pattern of March. Areas of the north received greater than 300% of the average for that period. And so again, we were making our forecast during this event. We did try to take it into account using what was being forecast for precipitation totals, but some areas definitely outperformed the projections. And so just keep that in mind as we go through the forecasts. Okay, so what does that mean for current snowpack? So both these maps are the model snowpack as of April 6th. The map on the left is just showing our significant areas in the model, and those are areas that produce most of the runoff volume. And you can see again, a lot of purple on there. There are some that's in the 200 to 300% range, some above 300% of normal snow. And so the shaded areas are the model snow. The square points are the SNOTEL stations. You can see they match up pretty well in their categories. Now the next map on the right includes all areas of the model where the median is greater than 0. So there's still some empty area there, but it's because we can't calculate a percentage when the median is 0. And just keep in mind that some of these areas that are being shown, the median is very low. And so it can really exaggerate the percentage that gets calculated. But we want to show these additional areas just to highlight that we do have a very unusual low elevation snowpack across much of the area. In the table on the far right, it's showing the percent of median model snow. And in the first column, it is from the April 1 value, and the last column is from yesterday, April 6th. And so you can see in the Bear, the Weber, Six Creeks, Provo, that percent of median value increased by 20% or more just due to this storm. The Duchesne did see a small increase. And then down in the Severe and the Virgin, you see some pretty big increases, especially in the Virgin, but that increase is more due to the lack of melt than to significant additional accumulation. And then here's the map from the NRCS, and it's showing the maximum rank of their SNOTEL stations. And what you see on this map are a lot of ones, meaning that in the Bear, Weaver, Six Creeks, and Provo River basins, those snow water equivalent values being reported at those sites are the highest on record. And elsewhere across the state, you see a lot of stations that are in the top 3 of the record. And here is a map from our webpage that shows the water supply forecast as a percentile rank. This is a new map that was just added this week because in a year like this, after a while, when you're looking at percent of average, I don't know if it's 250% versus 300%. It's hard to tell what that means. But what you see here, this map is showing the latest model guidance percentile, and you see quite a few black dots again in the northern Utah. And so that means that the latest model guidance is indicating chances for volumes that would be the highest on record at those points. And so this works just like everything else. When you click on one of those, you're going to get a pop-up. Like you can see, I've shown an example for Big Cottonwood Creek. And so the percentile ranking of that latest, yes, the model guidance is the highest on record out of 93 years of observed volumes. Okay, so now we'll move into talking about the water supply forecasts. So this is the map showing the entire state. Again, a lot of purple, meaning the forecasts, the volumes being forecast in those basins are in the 200 to 300% of average range, with some even above that 300. And when you look at the table, this is showing the median forecast percent of average in each of the basins. And so you can see the Bear and the Duchesne are the lowest, and those are over 150% of average. And then you get into the Weber, Six Creeks, Provo, we're looking anywhere from 215 to 260% of average. The Severes at 245%, and down in the Virgin, we're looking at 300% of average runoff. So just zeroing in on each of those subbasins, first we look at the Bear. So the April 1 forecast, we saw greater than 10% increases across the basin. Again, that median forecast for the basin is 160% of average, but forecasts range from 114 to almost 240% of average. So in this basin, no official 50% exceedance forecasts are over the record, but there is one, the Little Bear, where the latest model guidance, 50% exceedance is over the historical volume record for the April-July runoff. So here we have, hopefully you're a little familiar now with our ESP, our evolution plots. But just to review a little bit, the dark blue line that's on the plot is the ESP daily model 50% exceedance value. The blue shading is that raw model. The top is the 10% exceedance and the bottom is the 90% exceedance value. The pink vertical lines are the official forecasts at the beginning of each month. And so what you can see is on April 1, the 50% exceedance forecast, which means there's a 50% the final volume will come, 50% chance the final volume will be above that value, and there's a 50% chance it will be below that value. This is Blacksmith's Fork near Hiram, and that 50% forecast on April 1 was for 77,000 acre feet. The 10% exceedance, which means there's a 10% chance the volume could be higher than that number, which would be a wetter spring weather scenario. That number is 101,000 acre feet. And then down at the bottom of the line there is that 90% exceedance, which means there's a 90% chance it will be above this volume, which also means there's a 10% chance it could be below that volume. And this would be a drier spring weather scenario. And right now, that volume for the 90% exceedance is 65,000 acre feet. The other thing you can see then, if you look at that daily model guidance, is that with this storm that we just had, the model guidance already suggests that the 50% exceedance has increased to 92,000 acre feet from that 77,000. And this is due, you can see the plot on the right there is our model group snow water equivalent plot for the Bear River Basin. And so this is all the significant runoff areas snow in the Bear River Basin for our model. And it's increased 2+ inches across the entire basin as a whole since April 1. And so you can see 2011, which is also a pretty big year, we are now quite a bit above the peak that occurred for that snow water equivalent in 2011. Moving on to the Weber River Basin, again, forecast volumes have increased greater than 10% since March 1st. Median forecast of 215% of average, with a range of 158 to 309% of average. And again, no official 50% forecasts are over the record, but 3 points are over the record with using the latest model guidance, and those are the South Fork of the Ogden, Pine View Reservoir, and East Canyon Reservoir. Looking here at the evolution plot for Pine View Reservoir, again, you just see the steady increase in model guidance since the end of February, but especially with this latest storm. But what I want to point out here is that now we are into our runoff window, that April-July period. The observed volumes are important. We have to add those to the model forecast because the model is only looking from the current day forward so that we can maintain that consistent April to July total. So look for that. You'll start seeing more orange on the plots. And if the observed data is unavailable, the model guidance will be plotted as purple instead of blue to alert you to the fact that it is not indicating that full April-July period. Okay, Six Creeks, same story, big increases since last month. Median forecast 235% of average. Forecasts range from 180 to 325% of average. In this basin, we do have 2 official 50% exceedance forecasts that are over the record. That's Lambs Creek and Big Cottonwood Creek. And then 2 additional points are over that 50% that record using the latest model guidance, 50% exceedance, and that's Parley's Creek and Little Cottonwood Creek. And so here's the evolution plot for Big Cottonwood Creek. And what you see basically is we had a great start to the season. We had some steady increases in that model guidance from, during January. And then we did have a little bit of a dry period where the guidance decreased. But then, we've just been on, again, that steady increase since the end of February, thanks to this continual cold, wet weather that we've been having. And so the current forecast indicates that there's about a 70% chance of exceeding the historical volume of just over 66,000 acre feet that we saw in 2011. Okay, moving on to the Provo. Yeah, same story. It's really wet. Don't know. The forecasts here range from 164% to 326% of average. One official 50% exceedance forecast is over the record. That's at Salt Creek. And then with the latest model guidance, we have one additional point, and that's American Fork that could hit record. And then here we have the Duchesne, the Price, and the San Rafael basins. These ones saw a greater than a 30% increase in that April 1 forecast volume percent of average versus March 1. In the Duchesne, we have a median forecast of 165% with a range of 140 to 260%. In the Price and San Rafael areas, we have that median forecast is 215% of average with a range of 150 to 305%. So in this basin, while there are no 50% exceedance forecasts in either the official or in the latest model guidance that are over records, there are some of these forecasts that have a 10% exceedance forecast that is over the record. And I will say in those other basins as well, where, you know, there even points that didn't have a 50% exceedance over record, there are many that do have like a 10% that's over the record. So here's the model group snow water equivalent plot for the Duchesne River Basin. And I just want to point out that as of April 6th, we are basically have the same amount of snow water equivalent as we did in 2011 when it peaked, but 2011 didn't peak for another month. On May 4th, it had the same number that we now have in the model overall in the Duchesne. 2011 was a record year at a few of the points in the Duchesne River Basin. And so even though we are not, again, forecasting any, we don't have any 50% exceedance forecasts that are over records right now, we do have some at like that 10% exceedance that is over record as, and again, that would be a scenario where we remain wet and maybe cool and have a further delayed runoff. Okay, and then moving down to the Sevier and Virgin River basins, again, big increases. The Sevier median forecast is now 245% of average. The Virgin median forecast is 305% of average. Again, no 50% forecast over record, but we do have some over at that 10% exceedance forecast. So that was just a quick overview. Hopefully you all know how to get to any points of that you're specifically interested in for those. I just talked briefly about the verification of our April 1 forecasts. You know, what kind of error can you expect? In general, so you can see on this map, the color coding and the percent error over there. And there's a table with a couple of examples. In general, for April 1, we usually have quite a few points that are in that 15 to 20% error range. And again, just a reminder, we do better in kind of the higher elevation headwater basins where it's primarily a snow melt situation versus a lot of additional effects from rain. And there are known diversions and demands. We do worse in those lower elevations, again, where you can have rain during the runoff period that can affect the volumes. And there are upstream diversions and irrigation that we don't have the specific data for. And at this time of year on April 1, there's still a large portion of that forecast error that is due to future weather. Okay, so at this point, I'm going to transition from talking about the water supply volume forecasts, and we're going to go over peak flow forecasts. As I mentioned, we usually do a peak flow webinar in about the middle of March, but we were dealing with some high flows and flooding in southern Utah as well as Arizona during that time. And so, so we're going to go over it today instead. So here's just some background information, kind of an overview of the forecasts. So these are mean daily peak flow forecast point, and they're a subset of our daily river forecast points. Peak flow forecasts represent a long-range outlook of peak flows due to snowmelt. So these are not necessarily going to include, like, if we have a big precipitation rain on snow event on top of our snowmelt period. Many of these sites do have established flood stages and therefore provide some flood threat information. Peak flow forecasts have a high level of uncertainty and are highly dependent on spring weather. And so because of that, we typically do not forecast a specific date of peak until we really we see that maybe in a 5 to 10 day lead time. But we do give information on the normal peak flow timing, like a window for when the typical peak flows occur. Instantaneous peak flow records, we only get mean daily out of our model, but if there is a relationship, a good relationship between observed mean daily peak and instantaneous peak, then we can create that equation. And so it will only be available for locations with strong correlations and long historical records. And sites with frequent heavy rain have poor relationships. And just want to emphasize that peak flow forecast points alone are not a comprehensive summary of flood threat across the area. You know, we only have, first of all, we're not making peak flow forecasts at all points. And then secondly, not all of those points have defined flood level information. So now we'll just go over how you can access this information and where to find it. So we have a new drop-down menu on our web page that's labeled Peak Flow. The first option is the forecast map. When you bring that up, here's what you're going to see. In looking over on the far right at the menu that will be shown next to that. So this is a map view of the peak flow forecast points that are issued daily. These are locations with minimal upstream regulation. And there's going to be 3 different map views that you can choose from. The first one is a percentile map, then you have a percent average map, and then finally a National Weather Service flood stage exceedance probability map. And we'll go into each one of those in more detail. But I want to point out that there is help and documentation available by clicking on the little question mark buttons that you see over there in that right-hand menu. And clicking on any point on the map will take you to what we're calling the peak flow dashboard page. And again, we'll discuss that here shortly. So first, we're going to talk about the peak flow forecast percentile map. This is a map of the percent of historical annual mean daily peak flow values that are below the current peak flow forecast. So what that means, when you see the darker blue and over there in the legend you see greater than 90, that means greater than 90% of the historical peaks are below the current forecast peak. And so, as expected on this map, peak flow forecasts with a higher percentile correspond to locations with better snowpack conditions. And so you do see on this map a few black dots in the Great Basin area, meaning those are the highest on record. Specifically right now, this map is from the April 6th forecast run. And so you can see specifically East Canyon near Jeremy Ranch, McLeod Creek near Park City, and Mud Creek at Schofield. The latest model guidance indicating that 50% exceedance peak could be above the historical peak record. Moving on to the percent of average map. So this is showing the peak flow forecast percent as a percent of the 1991 through 2020 average mean daily peak flow. And again, it's similar to the other one. What you're going to see is peak flow forecasts with a higher percent of average correspond to locations with better snowpack conditions. On this map, again, lots of purple across the Great Basin, meaning many of the peak flow forecasts are greater than 200% of the average mean daily peak. And then the final map view here is of the flood stage exceedance probability. And this is indicating the probability of the mean daily peak flow forecast exceeding the flood stage. So here, peak flow forecasts with a higher exceedance probability correspond to locations with increased flood potential. And so you see a couple of red dots over there. That means there is a greater than 50% chance that the mean daily peak flow will be above the defined flood level at that site. What you also see here is a lot of gray dots, indicating that those are places we do not have a flood level defined. So just to point out, again, there are some red dots in the Great Basin. Those are right now the Barrett border, City Creek, and Big Cottonwood Creek. And again, noting flood stages are not established at all peak flow forecast locations. And then on any of these maps, clicking on a point takes you to the site's peak flow dashboard page, which is what we're going to talk about next. So there's a lot of information on this page, and so we're gonna break it down and kind of go through it piece by piece. But the first thing you'll see at the top of the page is this table and the peak flow evolution plot, very similar to our water supply evolution plots. So what you'll see here, these plots will include the 7-day precipitation forecast as a default. You can click on that plot and it will take you to a separate page where you can have, there are some other options that you can throw on this plot. But you will, in the table next to it, you'll get, if there's a defined flood flow, it will tell you what that flow is. It will tell you what the latest ESP 50% forecast. So here, we're just below that flood flow. This is the Logan River. Flood flow is about 1,550 CFS. The current 50% exceedance is at almost 1,500 CFS. And that rank of that 50% forecast is the 7th highest flow on record out of 69 years. And that means, and so looking at this, the percentile ranking, 91% of years are below the forecast. We don't have a peak to date, but as we get into the season and flows start picking up, that will start being generated. It tells you the average peak, the percent average of that 50% forecast of that average peak. It gives you the normal time of peak for here, May 13th through June 8th. and then it gives you what last year's peak was. So when you look over on the plot, you can see a lot of that information. The red dotted line is the flood flow. There's also a yellow dotted line, which is the defined bank full level. And then the green horizontal line is that average. And then of course the blue, just like I mentioned on the water supply evolution plots, the blue is a similar where you have the top of the shading is a 10% exceedance, the bottom is the 90, and the darker line through the middle is that 50%. So down at the bottom of the plot, we have observed stream flow. Now, while all the model information is mean daily, the observed stream flow is the instantaneous. And what you can see here is the line starts pink because up until about the beginning of March there, this gauge was ice affected. And so we don't have the observed data and we're just plotting the model, our model simulated flow instead. But then from March to the current time, you see the blue line, and that is the observed flow from the gauge there. Then we just further down on the page, you'll be able to access our latest 10-day stream flow forecasts. These are our deterministic forecasts that are done every day, every morning. And as the time of the peak nears, you really want to transition from using the probabilistic peak flow guidance to using this 10-day deterministic stream flow. In addition, for sites that have chances for hitting flood, some of them may hit flood before the peak actually occurs. And so you really want to keep an eye on these 10-day forecasts. And these forecasts do use that 7-day precipitation forecast and 10-day temperature forecast. Okay, as you continuing on down the page, you will also be able to get the tables of the probability of peak flow magnitude, as well as the probability of the peak date. And just want to point out that the probability of the timing of the peak is independent. So this is the probability of the timing of the peak regardless of what the magnitude is. And so in these long lead forecasts, what you're going to generally see in that timing table is that it will indicate the normal time of peak. But given the current conditions for this point, we have much above average snow and minimal melt to date. The model is indicating the possibility of a later peak date this year. And so I'm showing on here from the previous slide, the normal time of peak for the Logan is, May 13th to June 8th. If you look down in the table right now, it is indicating the 50% exceedance probability date right now is June 8th. And so again, because of the large snowpack and the fact that it really hasn't begun to melt yet, the model is indicating the possibility for that later peak. But again, this is very, very dependent on what the spring weather actually does. If we have a quick extended warm up, then that could definitely move that up. You can also get to the historical peaks, so you can see for yourself what has happened in the past. There's a table, and you can actually download the file if you'd like with that CSV link. And then another thing on this page is the snow conditions in the model snow that are helping to drive this. And so I'm not going to speak to that a whole lot right now, but just indicating, if you look at the green lines, the dotted is our lower elevation zone in the Logan. Usually that area should be almost melted out by this time of year, and instead it has quite a deep layer of snow. Okay, and then moving on from the map, you can also look at this in a list view. And so you can choose what specific area you want to look at to kind of, so you don't have so many points to sort through. In this case, I've chosen to look at the Great Basin. You can then filter and sort the data. You can see the sort by option there next to the choose area. So you could say, I want to sort by the percent of average or by the percentile condition. Then you can turn off and on some of the columns if you don't want to see some of those. And then from here, clicking on that underlined ID will again take you back to the dashboard page. And then finally, we do make some special forecasts, and these are generally points where upstream water management really impacts the downstream flows. And so basically reservoirs and diversions are above these areas that really affect them. So there aren't a whole lot in the Great Basin that we do special forecasts for. These require forecaster involvement, and they're only updated about twice a month. And so just as an example, the Green River at Jensen is one of those. It's driven by the peak from the Yampa, but also by planned releases from Flaming Gorge. And so in that case, we talk to the agencies that are running those reservoirs and double check with them on their plans before we put these together. And so I will just mention for this one, Green River at Jensen, right now there is a greater than 50% chance that it could exceed the flood stage for its mean daily peak flow this year. However, that is being really driven by the Yampa River, where you can see some red dots over there in western Colorado, and not by releases from Flaming Gorge. Okay, so that kind of wraps up the overview of our peak flow forecasts and how they're made and how you can get to them. And we'll just briefly talk about the upcoming weather. And so for the next week, April 7th through 14th, here's the precipitation outlook. And so what you can see, we do have some chances of precipitation across Utah. And basically that is the day 7 total. Right now, that's not a big total amount of precipitation because currently we're going to have a ridge of high pressure moving over the western U.S. And so we're going to see a period of dry and warm conditions coming into the region. Temperatures should be approaching seasonal normals by this weekend and could be 5 to 10 degrees above normal for the start of next week, with little to no precipitation through that time, through about the middle of next week. Then during the second half of the week, the ridge will start to break down and there's a trough that's starting to move in. And there's high forecast uncertainty at this time in the depth and timing of that trough. But current weather model ensemble guidance favors precipitation moving into Utah, basically on the last day of this forecast period. And then right now, when we talk about beyond the next 7 days, it looks like that trough should move through pretty quickly with another ridge building in after it passes. And so that kind of shows up in this 8 to 14 day outlook, which covers April 14th through 20th. And so what you see on these maps is really near normal precipitation and temperatures are expected overall for Utah in that week 2 outlook. But what this likely means is that we will have some days above normal and some below. So not that we're just going to have normal weather for that week. So that about wraps it up. And in summary, it's wet. The water year precipitation is much above average. Current snowpack is much above normal. Water supply forecasts are much above average. We have multiple points across the area with forecasts, those 50% exceedance forecasts above the historical record volume. Well, there aren't a lot above at the 50%, but at some exceedance level, they are above the historical volume. And in terms of mean daily peak flows from snowmelt, those are also expected to be much above average across the state, with multiple points again having a mean daily peak forecast above the divine flood level at some exceedance level. So that wraps up what we're going to talk about today. And just before we move into questions here, just a reminder, we do have one more water supply webinar scheduled, and that will be on May 5th. If you don't already know, here's how you can access to register for our webinars, but more importantly, probably down in this lower right, here's how you can access the recordings, this recording and previous recordings under the presentations, which I believe is under the About menu at the top. And then finally, here are the specific basin contacts, basin focal points to get a hold of us. But I will just say, if you have information that, or you need you have a question that needs an answer, it might be best to contact the CBRFC operations. Occasionally people actually do take a day off. And so this will guarantee that you will reach somebody and we can direct the question to the correct person. So with that, that is all I had to say right now. So if there are any questions that have not yet been answered, we can go over that now. Okay, so there is one question here about, so Laura Haskell, is there a way to switch the online map to basin view rather than station view, similar to the images in the early slides? So I guess the question is, what data type are you, here, I'm going to unmute you. So what data type are you asking about?
I was thinking kind of your forecasts and things, those first slides where you have all the basins in the different, this is 150% and this is 130% and all those colors. If I could see those online, or are they not available online?
Yeah, those are not available online. Sorry.
Okay, no, that's good. I won't look for them then.
Okay. Okay, are there any other questions? Okay, seeing none, I think we will wrap this up. Thank you so much for joining us today, and hopefully we will see you next month. Have a good day.